So graphing piecewise functions, basically you could look at it as almost being a puzzle. But you can only use certain pieces in certain spots. And it's a very weird notation, because right here you see f of x. I think we know that can be switched out in many cases for what? Or g of x, or just y. Right? F of x means y. So in other words, they're saying y equals x plus 2. If I were to ask you to graph y equals x plus 2, would that be overly difficult? Y equals x plus 2, you would be graphing a what? Parabola, the cubic thing that we did before, would it be a v? It's going to be a line, right? A line with slope 1 and y-intercept of 2, correct? And what if I just asked you to graph this bottom one, y equals negative x plus 5? Is that in itself all that difficult? No. But you notice over here, they're giving us more criteria. I'm only allowed to graph that one if the x value is less than 0. I'm only allowed to graph this one if x is greater than or equal to 0. What we're going to do is basically put those two lines together by following the rules. Right? Now, if we were to graph, now maybe just follow along for a second and then get the graph on there. If we were to graph y equals x plus 2, again, just wait for a second. We'll just do the whole thing. Do you agree y-intercept is 2? Slope is 1, so it'd be up 1 over 1. So the entire graph would look something like that. Do you agree? Again, just wait. Don't draw that in. But unfortunately, I'm not allowed to graph that whole thing because I'm only supposed to graph it when x is less than 0. Is the x value less than 0 over here? So was I supposed to graph that over there? I wasn't. Is this okay to have graphed that point over there? Is that less than 0 for an x value? Yeah, because what is the x value over there? It's up here, so what, negative 1, 2, 3, 4, about negative 7, right? So that's okay. And so what you have to do is kind of get rid of the stuff you weren't supposed to graph. I'm only supposed to graph if x is less than 0. So in other words, right there, and here's something you may not remember from Algebra 2, x equaling 0 doesn't actually fit into this graph. So this point 0, 2 actually is not part of that graph. Okay? And so what you do is you put a hole there. You don't fill it in. And so basically that's the top part of this graph. I graphed that line, I hope we agree with that, and I only graphed it when x was less than 0. And so I'll just get that out of there. I know I have it in there, so maybe. There it is. And you do notice it's an open circle right there. It does have a slope of 1. And if I did extend it, wouldn't it be the entire graph? It would, but you're not supposed to. So that you can actually get in there. That is part of the graph. You already told me that the other part is also a line. Well, what can you tell me about that line if we look at this other one? The slope is negative 1, and the y-intercept is 5. So if I was to graph the whole thing, we would go to a y-intercept of 1, 2, 3, 4, 5, and have a negative slope. Again, maybe don't draw it in right away, just kind of follow along for a second. So in blue, I basically graphed that entire line, correct? But I'm not allowed to graph that entire line. I'm only allowed to graph that blue one when x is greater than or equal to 0. So should I have graphed, say, this point over here? Was that okay to graph that one? Is x value greater than or equal to 0 there? Where I just put a dot. That's an x value of what, 5? How about this one down here? Was that an okay point to graph? Is x greater than 0 for that point? Yes, it is. So where are the ones I wasn't supposed to graph for the blue one? Okay, good way of saying it, pretty much second quadrant, because is this one, this is x equals 0 right there, correct? And does that have an equal on it? Yes, it says when x equals 0, you can graph this one, so that's fine. So in other words, what I should get rid of this time is, so how come the blue one's filled in and the red one's not? Yeah, because you see the equal to on there for 0? Okay, is it possible they could both have equal to? Yeah, they could both be filled in, and you would check that out. But basically, you just graphed that line where we were supposed to, and there it is. That red and blue line put together is the graph of that. It's called piecewise because there's lots of pieces, and you just have to put them together. Okay. Questions? Yes. Right, the red one right here at the end, at x equaling 0 is not filled in because there's no equal to on the red one. Because basically this was the red one. and this was the blue one, right? This one has equal to for 0, where the red one does not. So the red one actually should never ever actually have a 0 comma something value for it, ever. Now obviously, are they all going to be lines? No, we spent plenty of time working on parent graphs. So we know there's parabolas, we know there's V's, we know there's horizontal lines, vertical lines, and we've got the cubic, that little S-shaped kind of thing. We know a lot of that happened. Normally, for now, I'll stay away from trigonometry on the graph, so you don't have to worry about sine, tangent, and all of that for now. Let's just learn how to do the graphs first. But we do have another question down here, domain and range. Domain of this graph, remember, domain stands for basically the x values, and range stands for the y values. So let's try and make a note of which x values actually work here, or which x values actually have a y value that gets graphed. For example, if I put -10 in, should I actually graph a point somewhere? Yeah, it'd be down here, right? What if I put in -2? -2 for an x value, is there a point there? Okay, what if I put in 7? Is there an actual point there? Yeah, okay, what if I put in 10? Yeah. What about 0? Does 0 actually have a point that's filled in somewhere? Is it right here? No, it's up there. It's actually filled in, right? So is there any x value you could give me right now that doesn't actually have a point? So in other words, every single x value works. I'm going to show you a nice notation that's going to save us a ton of time in calculus. You agree we could do it the inequality way, but that takes forever. Here's a nice notation you can use. It's called interval notation. You can basically say it goes from -infinity to +infinity. Doesn't that pretty much cover all the x values that work? Okay. The hard part about this is it almost looks like an ordered pair, doesn't it? So we have to know it's interval notation, and if this is the question, we know it's interval notation. But that's the only problem with it. And we have parentheses there, because can you really ever get to -infinity and +infinity? Can you ever really get there? No. So we put parentheses, because it's not really included, because you can never really get there. If it's included, you use a bracket. And I'll show you that in a second, actually. So can you tell me in some way range against its y values? If you look at every single y value, again, kind of look horizontal, does every single y value get taken care of? So basically, does y value of 5 actually get graphed? How about a y value of, say, 2? Y value of 2 is right here, right? Yeah, it gets graphed over here, right? How about a y value of -10? Would that eventually get graphed? Actually, blue and red, right, would both get it. That's okay. It just has to be once. So you're telling me up here, though, would not, up above 5? So if you like to, you can stick with the old way. You would say that y has to be greater than, or excuse me, less than or equal to 5. That's a way that you can write that. That's fine. But I'm going to show you what that looks like in interval notation, just so, again, this is stuff that hopefully then when we do it in calculus or do it at the next level, you will have seen it before. It's 5 to -infinity. Do you agree it keeps going down into the negatives, right? But 5's included. What did I just tell you to do? If it's included, use a bracket. What's a bracket look like? Yeah, a lot of you are kind of doing kind of the box or square it off. Yep, that's how you do it. That tells everybody that looks at that interval notation that 5 actually works. If I were to put a parenthesis on there, that would mean that 5 isn't included. And how would that happen if there was open circle there at 5, right? That's when that would happen. So a lot of stuff thrown at you there. Got interval notation and graphing, basically just little pieces. Like I said, it's like a puzzle. Okay, any questions? You've had some good ones. Please realize there can be more than 2 pieces. I could give you a 27-piecewise function. Okay. That'd be a lot. I won't do that. I think 5 or 6 is the farthest I ever go. This one has 3. So let's just, what I want you to be able to do, and what's going to be very helpful for you, is to be able to look at them. The first one is basically saying y equals x plus 2. What's that going to be in general? A line, right? How about y equals x squared? Just in general. Parabola that opens up. And how about that last one, the negative square root? Yeah, I see a lot of you kind of doing this. It is basically this one, because remember, positive square root's up here and the negative reflects it. That's where the parent graphs come in. So could I teach this there? Yes, I could, but I found this is a really good place to review all of that stuff, because parent graphs aren't on the finals. Okay, so let's just go ahead and graph one at a time. So we'll say this one we're going to do in red. And I'm only supposed to graph when x is less than -1. And so what some people do is they just put in a bunch of values to kind of figure out where it is, but just make sure only choose x values that are less than negative 1. Okay, but what I normally do is I put in negative 1 right away just to find out kind of where it ends. So if you put in negative 1, what's the actual y value? Again, it's y equals x plus 2. And so put in negative 1 and you get a positive 1, correct? So negative 1, positive 1, will that be filled in or open? Y open. Yeah, is the equal to here? No. So should I plug in 0? Does that seem like a really good choice to substitute in 0 for that one? Why is 0? Yeah, why would you plug in something that you're not even supposed to graph? So can I plug in negative 2? Yeah, so you put in negative 2, what do you find out? Negative 2 comma. Can you plug in negative 3? Is that okay? You plug in negative 3 and you get negative 1. And you already told me this is a line, right? So don't we pretty much know that we can just finish this one off and just kind of go like that, right? And does that make sense? It's a line with a positive 1 slope and y-intercept of 2. If that kept going, do you think it would have a y-intercept of 2? How come it doesn't? Because we were told to stop. That's why it doesn't, right? So you're telling me, what's this next one again? Y equals x squared. We'll do that in green up here. Y equals x squared. Do you think 7 is a good x value to try and put into that one to figure out where it is? 7 a good choice? No, for one, the y value is 49, so horrible choice. And the second one, it's not even in the interval here. Should I put in negative 1? Yeah, put in negative 1. Now be careful. Put in negative 1, you get a positive 1. So you're saying negative 1 comma 1, it gets actually filled in by the green one, right? That's actually a point. Should I put in 0? Do you think that's a good choice? Yeah, what do you get when you, because again, is 0 in this range? Yeah, let's find out where these points are. You put in 0 into there and you get 0, okay. Is 1 a good choice or should I stop? Or should I stop at 0? No, 1's a good, it's still in the range. So put in 1 and you find out it's 1. And then should I put in 2? I know it says that it's not included, but I always put in the end numbers. Just put an open circle there. So put in 2 and you find out it's 4. So 2, 4, and what did I say I should put there? Open circle. And don't we know that this is just a big parabola, right? But we're only graphing a little portion of it. And so try and make it look like a parabola the best you can. Don't just connect it with straight lines, because you know that's not what happens. You know that's a parabola. How are we doing so far? Is the color coding helping? I'm hoping it is a little bit. I'll put a little check mark that's in green. And in blue, we will save this last one. This is probably the hardest one, that's why I have it in last. But one of you remembered kind of what that parent graph just in general looked like. Remember that positive x squared kind of did that. And so negative x squared is going to kind of do that. And so we at least know about what it's going to look like. And it has been moved to the right 2 and up 4, if you remember how to transform things. Or just put in points. Let's put in 2. Was I at least nice with the points I stopped at? Yeah, I could have been much worse than I was. Why was 2 such a nice point? Because when we put 2 in here, 2 minus 2 is 0. Square root of 0 is, put a negative on it, well, that's still 0, right? And so it's basically 2 comma 4. So in other words, the blue one fills that in, doesn't it? Trust me, that doesn't always happen. They don't always get filled in. Because you put in 2, it's 4. Very good. Why is it open? Very good. See, no equal to. So does that point ever get filled in? That hole is going to be sitting there the whole time, isn't it? Yeah. All right. Now, what's probably the next easy point to choose? Actually, yeah, 6 or 3 actually works very well, right? So let's put in 3. 3 minus 2. This is why they're saying it's good. It's 1. Square root is, don't forget about the negative. Negative 1 plus 4 is. Now, let's not forget what value I just put in. I put in 3, and I found out it was 3. Okay, so 1, 2, 3, 1, 2, 3. Now, is this following what TJ was kind of telling us? Is it going to make that? Remember, it should look something like this. Remember, 3 minus 2 is 1. Square root of that is 1. Negative 1 plus 4. All right. And then I was told 6 was another good choice. Why would 6 be a good choice? Yeah, because 6 minus 2, perfect, is 4, right? Square root of 4 is 2, that you make negative, so it's negative 2, plus 4 is 2. I think we should all kind of say that one, all right? But what x value do we put in? Again, is this following We know what this does. You already showed me, and so we can stop and say, there it goes. And as you realize now, the more pieces we put in there, the more crazy the graphs can get. In a way, yeah. If you color code them, it's kind of like Legos, I guess. Yeah.
None of my Legos curved.
No? All right. Domain, you can write it many, many different ways. You can use the interval notation if you like. But then again, basically, domain is which value again? X, okay. This one's Y, right? Okay. So again, pick some X values and see if they actually get graphed. For example, -8. -8 for an X value, is that good? Yep. How about 10 for an X value? That's fine. Basically, there's only one that causes a problem. That's an X value of 2. Do you agree? X value of 2 is the only one that doesn't actually have a point because we did not fill it in. So what's probably the easiest way? I would just say all reals except X equaling 2. If you want to know what that looks like in interval notation, I'll put it up there in a second. Because I'm a big fan of interval because you can do it so fast. Interval notation would be isn't that saying the same thing?
Yeah.
Basically saying 2 is the only one that doesn't work. It looks weird, but I'm saying 2 is the only one that doesn't work. Again, this is interval notation. I know it looks like an ordered pair for the student that just came back in, whose name should not find its way onto any more recordings. This is it's saying basically right here that all of these values would work for X and all of those would work. A parenthesis means that 2 does not. And we never put brackets around infinity because you never get there.
Got that, Banana Kuiper?
Can you say my name?
Banana Kuiper. Banana Kuiper.
When I'm old and my kids are learning this, they should go back.
All right. How about range?
I could have just tossed off.
I think range is actually a little bit easier to do interval notation, to be honest with you, but you could do it this way. You could say, oh, yes. No. What about y equals 5? What about y equals 10?
Okay, everything above y equals 4, so do we bracket?
Below. So what you could say is all reals, this is one way you could say it, where y is less than, should I put the equal to on that inequality? Why? Because does 4 as a y value ever actually get graphed? 3.9? Yes. In fact, 3.9 gets graphed twice for a y value. But 4 never does. If you went interval notation, you'd probably say -infinity to 4, and boom, just close it off. Again, if 4 was included, you just put a bracket on it. Yes? There's a lot of ways. What I do for domain, a lot of times, believe it or not, is I don't look for the ones that work. I look for the ones that don't. Okay, because I basically, when I do range, I look horizontal. I say if I was throwing lines in here, would I actually hit this graph somewhere? If I went down to y equals -10, I drew a horizontal line, a huge one. Would I actually hit this graph somewhere? I would be over here in red, right? What if I went up to say -1, drew that line, would I hit the graph? I would. Only once, but that's all you need. Here at actually +1, I would actually eventually hit the graph 3 times, right? But all you need is 1. If I went up here to 4, that horizontal would that horizontal line ever hit the graph of points? Right, as in the ones we made. Yep. It just stops because that's where we were told to put the green one, from -1 to 2, but not including 2. We were told to just, yes, there's a huge parabola there. We were told to look at just this little piece of it and don't look any more at it. Yep. So yeah, once you get it graphed, that's when you should try and do these. Don't try and do it beforehand because you're going to see that parabola and be like, oh, it gets them all, you know, because we know that. But only look here. And so if you look at, say, y equals 8, that never hits. And so again, I look for the ones that don't and then try and specify kind of after that which ones do. Because you notice here, knowing which one didn't, help me fill out this form, negative infinity to 2 to infinity, because I just had to find the one that didn't work. Okay? Good question. Anything else? I know it's different, but you can do it.